This is a USB-C extension cable. I was sent this to review for free. If you wanted to purchase it, this cable costs $30. So technically, a USB-C extension cable like this, male to female, is not included in the USB-C specifications. So it works, but it's unofficial, if you will. And this particular one has some pretty high specs. So it is claiming 16K Ultra HD video transfer. It has Thunderbolt 5 compatibility, 250 watt power transfer, and so essentially this cable, and also 80 gigabits per second data transfer. And so this cable is pretty premium. You know, it claims it can do all kinds of stuff. And I don't have the equipment to test all of that. I will throw 100 watts through it just to make sure it doesn't overheat. Now, it feels very nice. It has a braided cable, it's pretty thick. It has nice molded ends here with all of the ratings printed right on it. Now, essentially the reason these cables can be dangerous is that if you have a cable plugged into them, any device will read the eMark chip on the cable plugged into them, and this cable here is a straight pass-through. It doesn't have any like eMark chips on it. And so if you had a cable that was a 500 watt cable plugged into this 240 watt cable, and some device actually drew 500 watts through the whole thing, you could potentially overheat this cable. But realistically, since this is a 240 watt cable, I don't think you're going to get yourself into that type of a situation. So it's probably perfectly safe to use this guy. I plan on using this cable mostly when testing USB-C power delivery devices. Sometimes I want to put a meter, plug it into a device, but the location's kind of difficult, and so I need to extend where it comes out. So I'm basically just looking for a cable that does at least 100 watts, just so I can put my meter in a nicer location. So without the extension cable, I'm getting basically 95 watts. With this extension cable plugged into my load, it's negotiated up to the 20 volt level, 4.8 amps, 95 watts, and that's really being limited by the source here. And here I'm getting about a 42 megabytes a second. Right, I'm going to repeat that file transfer through the extension cable here. We're getting 38, 39 megabytes a second. So just hit 40 right there. So just 1 or 2 megabytes per second smaller. Alright, so doing data transfer through this cable was measurably slightly slower, you know, maybe 40 megabytes instead of 42 megabytes, and that might just be an extra, 1.6 feet of the cable. It really didn't seem to be slowing down data much at all. The power transfer here is basically the same as without the cable. I'm going to leave this guy running for about 15 minutes and then come out with a thermal camera just to make sure it doesn't have any spots that are making undue resistance. Okay, we've been pushing 95 watts through this cable for the last 15 to 16 minutes, and it looks very reasonable temperature-wise. You can see that the source cable and this cable here are both about the same warmth. The real heat is at the load, which is having the power going into it. And there's a little bit of a warmer spot where the thing goes through the meter and goes through two connections at the meter. This cable here is barely warm to the touch. My hand is probably a little bit warmer than the cable there. So it looks like it'd be just fine to put USB-C power delivery power through this cable for a decent amount of time.